for lesson 15, we're just going to kind of sum up and bring together all of our quadratic equation solving. So the opening exercise says, are 4 plus or minus 2 square root 10 the solutions to the equation x squared minus 8x equals 24? So basically, I want to check what the solutions are here. When I see solutions that look like this, I know that factoring would never ever get me there. So I'm going to have to do either completing the square or the quadratic formula. Well, no matter what I'm doing, I need to set this equal to 0. So minus 24 minus 24, x squared minus 8x minus 24 equals 0. Kind of up to you on which method you want to choose. I feel like we've probably done a lot of quadratic formulas, so maybe I'll complete the square here. So then we get x squared minus 8x plus a line minus 24 minus a line. So negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So plus 16 minus 16. We know that this factors to x minus 4 squared. And then negative 24 minus 16 gives us negative 40. So we will add the 40 to both sides. X minus 4 squared equals 40. Square root. 40 is not perfect, but 40 does split. Square root 4, square root 10 comes back together. X minus 4 equals plus or minus 2 square root 10. And then we will add our 4 to both sides. And we get x equals 4 plus or minus 2 square root 10, which does match what we had in the beginning. So the answer is yes, that those are the solutions. In the next one here, it says g of x is 2x squared. I just want to see what the bottom says. Oh yeah. So gx squared equals 2x squared plus 3x plus 10, and k of x equals 2x plus 16. Solve the equation g of x equals 2k of x. So we got to be careful on that piece. Algebraically for x and to the nearest tenth. So again, if I see nearest tenth, there's a good chance that factoring is not an option. So I'm either going to have to be quadratic formula or completing the square. But let's set this piece up first. So g of x, 2x squared plus 3x plus 10 equals, and then 2k of x. So 2, and then k of x is 2x plus 16. All right. So now we know we have to set it equal to 0, but the first thing we have to do is we're going to have to distribute. So 2x squared plus 3x plus 10 equals 4x plus 32. Now we can set equal to 0. So minus 4x minus 32, minus 4x minus 32, 2x squared minus x minus 22 equals 0. Again, so factoring is probably not an option. We just did completing the square, plus there's an odd value here in the middle. So I'm thinking quadratic formula is probably the best. So a is 2, b is negative 1, c is negative 22. X equals positive 1, plus or minus big square root negative 1 squared, minus 4 times 2 times negative 22, all over 2 times 2. So let's see what we got here. So negative 1 squared, sorry, not plus, minus 4 times 2 times negative 22. That gives me 177. So x equals 1 plus or minus square root 177 over 4. 177 is not perfect. I do not know if 177 splits. So we'll go to our calculator, and if we look here, 3 and 59 doesn't help us. Everything else down the list appears to be decimals. So it doesn't appear that it splits. Now, actually, as I think about it too, if it is going to split, or if we're going to round to the nearest tenth anyway, it's kind of irrelevant if we split it, because we're going to let our calculator do all the work anyway. So we have 1 plus square root 177 over 4, and 1 minus square root 177 over 4. So calculator here, alpha y equals, to get my fraction, 1 plus the square root of 177 over 4. To the nearest tenth, that gives me 3.6. And then we'll do the same exact thing again. Only difference is we will be 1 minus the square root of 177 over 4. And that gives me negative 3.1. And those are going to be my two answers there. And it says, explain why you chose the method you used to solve this. Well, irrational answers can't come from factoring. All right, so that eliminates factoring. And then the last piece is odd b values. Okay, now we should know that when we have odd b values here, like we had negative x, make completing the square hard, right? So we know that completing the square becomes much more challenging when there's not an even number in the middle. So quadratic formula is the easiest, realistically, of those three options there. I want to skip to the bottom of the picture frame here, number 4. And the reason I want to skip is because we did a lot of these questions back in the last unit, but we didn't know how to solve for them. We just knew how to set up the equations. So now we're going to look at how we do some solving. So a regular picture frame measures 6 inches, or regular picture, measures 6 inches by 8 inches. Simon wants to build a wooden frame for the picture so that the frame picture takes up a maximum area of 100 square inches on the wall. The pieces of wood that he uses to build the frame will all be the same width. Write an equation or inequality that could be used to determine the maximum width of the pieces of wood. So there's Simon's picture. It's 6 by 8, and then he wants to put the frame around it. And all those frame widths are x. Okay. So now what do we need here? Well, we need an actual length. So it's x plus 8 plus x, which is 2x plus 8. And then x plus 6 plus x, which is 2x plus 6. So those are going to be our new length and our width. We know the area of a rectangle is length times width. So 2x plus 8 times 2x plus 6. Now it says equation or inequality, so you can use an equal sign for the area of 100, or if it says maximum, you could also use less than or equal to. It's kind of up to you. Because it stays consistent with what we've been doing, I'm going to use the equal sign. Explain how your equation or inequality models the situation. We're going to skip that piece just in an effort to save a little bit of time. But remember, what we've always talked about is that the 2x plus 8 and the 2x plus 6 represent the total length and width of the picture frame. And then since area of a rectangle is length times width, we multiply them and set them equal to the 100. So solve the equation or inequality to determine the maximum width of a piece of wood used for the frame to the nearest tenth of an inch. So there's that nearest tenth again, probably not factoring. So if I recopy it here, it looks like it's in factored form. The only problem is, since it's not equal to 0, it's equal to 100, we can't actually factor it right away. So what we have to do is we have to multiply the 2x plus 8 and the 2x plus 6 in our boxes, and then we can work on solving from there. So 2x times 2x is 4x squared, 2x times 8 is 16x, 2x times 6 is 12x, and 6 times 8 is 48. So we've got our like terms here in the diagonal. 4x squared plus 28x plus 48 equals 100. We'll subtract our 100 on both sides. 4x squared plus 28x minus 52 equals 0. Now you could work on completing the square because you could GCF this, but the problem is once you do that, you're going to end up with an odd number in the middle, which we know makes completing the square a little hard. So I'm going to choose quadratic formula. So A is 4, B is 28, C is negative 52. So x equals negative 28 plus or minus 28 squared minus 4 times 4 times negative 52 all over 2 times 4. So we'll go to our calculator here. We'll probably end up with a fairly large number. So 28 squared minus 4 times negative 52 gives us 1616. So x equals negative 28 plus or minus the square root of 1616 over, and 2 times 4 is 8. Now normally we would look at solving this, or excuse me, simplifying the radical, but if we're going to end up rounding to the nearest tenth, it doesn't matter. We're just going to split it and do negative 28 plus the square root of 1616 over 8, and negative 28 minus the square root of 1616 over 8. All right, and now it's just all calculator work from here. So let me put it into a fraction first. So negative 28 plus the square root of 1616 over 8 gives us 1.5. And then negative 28, fraction first. Negative 28 minus the square root of 1616 over 8 gives us negative 8.5. Now, we're talking about the width of a picture frame. We know those are not allowed to be negative numbers. So what is our width going to be? It's going to be 1.5, I believe we're in inches, yes. 1.5 inches will be the width of our picture frame. So a little bit more of a challenging solve, but we set these up a lot earlier in the unit and last unit, and now we know the complete way to solve for them.